Hi everybody, so I'm going to show you how to take a D3 plot from LS-Dyna and get render quality videos from a simulation that traditionally looks like this to something that looks like this. So this is just like a can crush simulation that I have in LS-PrePost, and traditionally what you do is you would probably go in here, if you don't have any other software, that is, if you only have PrePost, you come in here and you get a video from up here in File, and then you go to Movie, and then you'd output a video. And you'd first probably want to turn the mesh off if you wanted to get a good quality looking video, and it'd look like this. So something you may have would look like this, right? So it doesn't look too bad, but it doesn't look great either if you're really trying to get something that looks realistic or representative of what you're modeling. So another option you can do in PrePost, which I've gone over, is you can go into View and then into Smooth Shade, and it's actually going to smooth out all of this and really make it look a lot smoother. But you're still kind of restricted by the resolution of PrePost. So you see how you have these jagged edges, and that's really going to restrict the quality that you get out of it. So what you get with the smooth animation, you get something like this. So you see how it's kind of fuzzy. The resolution's not great in the videos. But if you need something quick, this is not bad, But if you really want something nice, like this render I showed, I'll show you how to do it. And it's through a program called Paraview. And before we get into it, just remember that there's two types of looking at animations. You have parallel, which is like this, where there's no depth to the animation. And then you have perspective, which is like this. So wherever you're looking at, it changes how the objects further away from you are appearing. And perspective mode is available in PrePost, but I think it's a little too dramatized. I don't know how to say it, but it's almost too much. But that's here, and what I showed was actually in perspective, so we'll get into it. But the software I mentioned is called Paraview, and I'll put a link to download. It's free to download. It's a little tough to learn. It's mainly used for like fluids and streamlines and that type of stuff. But there is ways to actually get D3 plots and render them, and I'm going to show you how to do that. So what we first want to do is open up Paraview here. When you open it up, it's going to look like this. I'm using 5.7.0, and I'll supply links for all of this. And what you're going to do is you're going to go to Open, and then you're going to find your file location. All right, and then you're going to double click on your D3 plot, and then you're going to hit Apply. It's going to load it up. And before we go further, the controls, so hold Control, right click, pull in to drag, similar to PrePost. Hold Control, left click, or no, don't hold Control, just left click to rotate around. And then these are like preset views up here. And then you can also just zoom in and out. I actually don't know, you actually don't have to hold Control. I get so confused between all these software, but this is what it looks like when you open it in. So you still are restricted by the mesh at this state. So down here is kind of your timeline. And I'm not an expert in Paraview by any stretch of the imagination. I'm just trying to help you guys get good looking videos, and I'm going to do that. But this is like your timeline, and your millisecond range is what I'm in. So 0 to 100, that's how long the simulation is. And you can change this. So this is snap to time steps. So this was a very fine animation I made. So there's a ton of time steps. There's 1,000 or time stamps, however you want to say it. But you see, you're still restricted by this mesh. So we want to change that. And if you want to change the sequence of how many timestamps there are, what I have been doing is go to sequence, and then you can put like a start time, end time, which is just the end. And then you can define the number of frames you want, and then you can hit play up here and it'll step through it. So this method that I'm going to show you, if you ray trace, it's going to take a while to do and a lot of RAM. Just get that out of the way. If you don't have 16 gigabytes of RAM in your computer, you won't be able to do ray tracing, but you can do normal rendering without like shadows, and you should be fine with like 8. But let's color the stuff in this first. So this color map over here is mainly for like stress fields, but what I've just been doing, just quick and easy, you can just double click here, so this white is corresponding here, and I'm just giving it red and some kind of dark red. There you go. This one's corresponding up here, so I just double click it and give it white. You're not white, we'll go gray. This one's blue, so that's make these almost black. And then this one's similar. I guess you can just do that. And then there's this green one, and that is a pull tab on the top. And so when you're in here and you want to hide one of the objects, I just right click and you can hit hide block. Whoops. And see there's this green pull tab. I have another video on how I made this, or actually I don't have one on how I made it, but I have a video on like the simulations of the can. I can do one on how I made it too if you guys really want. But everything I did was free to use stuff. But so there's everything's colored now. And if you want to add that block back, you can just hit show blocks by right clicking. So this is what we got. Perspective is on, as you can tell. And you can turn perspective off. I'll find it. For now, it's just going to stay on because I can't find it. Oh, here. Camera parallel projection. It's right here. If you do that, it's going to make it like standard pre-post. Small tangent, but there you go. But we're mainly going to stick to down here. So we got everything colored that's here. If you don't want this color map on, you can use this slider, make sure properties is open, and you can scroll down to this area that's coloring and just click off of this. That's the color map. And then the triad is down further, and it is here. It's the axis. I'm going to click off on both just to get it out of the way. Scrolling down this is all output stuff. I'm not even going to get into it right now. This is coloring. This is rendering lines as tubes. If you have lines in your simulation, you want it to render as like a 3D object, you can click this on. And here's your lighting and all of this. So your lighting is actually going to be important. So you want to leave this on. I actually don't know how to pronounce this. Ground, I think. You're going to leave this on this. It's like a smooth lighting type of lighting. So the standard light is just going to look like this. You can leave this on or you can turn it off. I'm going to go over how to manipulate it really quick. So if you don't want to, you can just skip ahead. But if you want to change this, you go up here to view and then click on light inspector. And then it's going to show up down here. And this is what I was talking about with the memory. So we're already up at 10 gigs. So you're going to need 16 gigs of RAM. But in the light inspector, you're going to click off of light kit. You're going to click enable light 0. And you're going to leave these scene. You can make this 1. You can make it 0.75, whatever you want. I'm going to make it 0.75. Directional. And you can mess around with these. I'm just not going to really get into it. And then your position. So I added the triad back just so you can see where the coordinates are. Because this is going to determine where the light is. And you use these coordinates to position the camera. So the position of X, I'm going to put the light up here, kind of in front, to give it a little shadow this way. We're going to make this like 200. And it should be in units, so that's too much. 100. It's still too much. Oops. Yeah. 50. All right, 20. There you go. And then this is Y, which is up. So we're going to make that 100. Too much. All right, so 70. So that's perfect. And then positional 1 is Z. It's just in this direction. So that looks pretty good, but we have the light there. Then you can come back here to the lighting tab. The spectacular power is like the shininess of your material, your object. I'll leave that at 100. Lumosity, I'm actually not sure what it is. Ambient, so we're going to put this at like 0.07. And it's just going to give you like a ambient light around. So if you turn it all the way up, like really high, it's going to brighten everything up. But if you turn it down all the way, it's going to not have much at all. So we're going to leave that around 0.07, 0.08. And that's it for lighting. So we're going to move on. But for now, this is what you got. So before we go further, I can show you what this is going to look like in a video. And we're going to leave this at 50, so 50 frames, 100 millisecond in time. So this is what you're going to look like if you render, or not, yeah, if you render this out. So as you can see, that's not bad, but it's not ideal. You still have, you know, that coarse mesh. So we're going to fix that right now. So Paraview works with these things called filters, and it's not what you think it is. It's more of like manipulators. So first thing we're going to do is click on the D3 plot. We're going to right click it and hit add filter, and then go to alphabetical. And we're going to go down to extract surface. And then we're not going to change anything on any of these. We're just going to hit apply. That's done. We're going to right click on extract surface, go to add filter, go to alphabetical. And we're going to go to triangulate down here. What this is going to do, it's going to split up all of the elements in the model into triangles and make it really small. So it's going to increase the element number of the model by a lot. So then what you're going to do is go to triangulate, right click, add filter, alphabetical, and subdivide. So this is what I'm talking about. This is going to break up the each element is going to subdivide it into smaller elements, which is going to increase the resolution of your D3 plot. And then you're going to right click this, add filter, and then we're going to extract normals. So, or generate surface normals, and then hit apply. So the light has turned off again. So what we have to do, or the spectacular, it's just not shiny right now. So what you have to do is go back down to the camera, spectacular, make that 0.75. So there you go. So you can already see how much smoother this is. It looks a lot better. Move this back to this. So it looks 100 times better. You still see a little rigid edges on the edge, like at these really creased parts, but it still looks a lot better. And whenever you do all these filters, it may bring these back, but you can just like rehide them here. Then I'm going to rehide the axis. So now that we have this, I'm going to show you a video of what this render is going to look like. So it'll look like something like this. So that is not going to take too much RAM. You should be able to do that with like 8 gigabytes of RAM and a reasonable graphics card. I'm not sure if you can do it on like a laptop, but that's not too crazy and too computationally expensive. It may just take a little time. But it's a good video. It looks a lot better than the output that PrePost would give you. Now, what we're going to do is take it a step further and actually ray trace this. So ray tracing is something that actually projects light rays onto a surface. Trying to explain it correctly. I'm probably going to butcher that, but just think of it as a way to get shadows. So you see after I clicked it, you already have these shadows. There's two types in here. You have raycaster and path tracer. From what I've seen, path tracer is more realistic, but raycaster is a little faster. So if we look at raycaster, you're going to have something called ambient samples. So just make this 1, and then it's going to brighten everything up. And you're going to see all these dots, and these are the individual rays that it's projecting onto your surface. So if you want to increase the resolution of this, you have to go down here to samples per pixel, move this up to like 10 or something even higher, and hit enter. So there you go. And now you can see the shadows and everything looks really, really nice. And you're going to want denoise to be on. And then progressive passes is something where you'll start with these lower resolution images, and it's going to go through and progressively increase the resolution of this. Or not the resolution, but the raise of this one step at a time for each image, and then move to the next. I'm not going to get into that right now because you have to do like a special step and launch Paraview through the CMD, and I just don't want to do that right now. But if enough people ask, I'll do another video just for that. But you can get good enough videos without doing that. So I will turn ambient back to 0 and move this to path tracer. So this is what you got to start. I'm going to move this. So if you want to move stuff around while you're in here, I would suggest leaving this at 1 or just turning ray tracing off until you have your model where you want it, because otherwise it's going to be super slow. So just a tip on that. So we're going to turn it back on. And path tracer, and we're going to move the ambience or the samples per pixel, move them to 15 for this. I found this was pretty good, and you see it looks really, really nice. And what you're going to do is, okay, I haven't shown how to actually export animation yet. Before you do any of that, you want everything set up. Make sure it looks all good, because this stuff could take a long time. Make sure your individual time steps or timestamps are how you want them, and that you're not looking at something that's like this, where you have gonna be super coarse. You know, it's gonna look really bad. Oh, and I'll show you. Yeah, this is what it's gonna look like. But you also don't want your timestamps to be. You don't want too many, because then it would take ages. Like if I did mine snap to timestamps, it would have to render 1,000 pictures, and it would take a long time. Probably crash my computer. But if you want to export an image, I'm gonna start with an image. We'll go to a point that looks pretty good. So we're going to export this image. Go up here to File, go to Save Screenshot. You're going to go to wherever you're at. What's wrong with me? Okay, and then we're just going to say test, and then okay, you can select whatever file you want. Okay. And it's going to bring up this window. Oh, it crashed. So that may happen. This can crash on you, but if you're afraid of it crashing, this is a great, here you go, great learning for everybody. You have everything just how you want it, and you don't want to have to redo everything when it's going to crash on you. Go up here to File, hit Save State. And then you can call it whatever you want. So test. I've already done this for a lot of these because I've had it crash a lot and I'm tired of doing it. And you save it. And then if you want to open a state back, show you how to do it. You just go to load state, but I'll actually do it. So go in here, File, Load State. And just click OK, hit OK. And it's going to load it back exactly how you saved it. That is super important. So I may just tag this in the description as like a really important thing, because this will save you from banging your head against the wall. Moving on though, let's try and save a screenshot one more time. If you go to File, Save Screenshot, and then let's just put one here, test, okay. Don't crash. Okay, it's fine. This is going to show up. And it's going to default do the image resolution of this window. This may give you problems. So you can do whatever it is standard. You can also hit the lock and move it up to whatever you want. So something like 1920 by 1080. And then hit OK. And now save it out. And there you go. So there's your image. There's one thing that you have to do different with video. So that's how you do screenshots. You can change the resolution. if you have this, and that's on time steps, change that back. If you want to save out an animation, it's very similar. So you go to File, Save Animation, and then I'll just say Test. And then you can hit OK. And a similar window is going to pop up. And if you change this with this window being this small, you change its resolution in this version of Paraview, it's going to do weird things. It's going to do something like this. We have like this weird quadrant picture in the picture. It's bizarre. And then from there on, there's like this faint like cross hatching. You can probably barely see it. And it's really obnoxious. It took me the longest time to figure out why it was happening. So you're basically, I was stuck in this resolution. If you want to fix that, what you have to do is click on this right next to this window, and it's going to actually pop this window out to the size of your screen. So I'm going to do it. And you can hit maximize. There you go. And this is overlapping my Paraview screen, but what I would do is move this to a different window. Or you can do, I think it's Control M, perhaps. So you'd want to move this to a different window. So this is going to be a restriction for people with one monitor. But I don't know what the shortcut is for save animation. I can probably look that up. What you're going to do is maximize this to the full screen, then hit save animation, and then leave the resolution at whatever is default for your monitor. So right now it's 194 because it's this big, but when this is maximized, it'll be like 1900 if your screen is 1080p. So if you do that, then you're going to get good pictures. You can also change your quality. I usually just leave it at 2, and then the frame rate I put at 30. So once you do that, you're going to get an animation that looks like this. So it looks really good. This is like render quality animations, and it's really cool. You can do this with d3plots because I had no idea, and I've been doing this for a while. I didn't know you could do anything better than PrePost. There are other programs that do stuff like this in a little more efficient time, and they look very similar. One's Meta. It's through Beta, CAE, and it's the program called Meta. It's their post processor. You have to pay for that, though, and not everybody has it. But that works really well. This works really good, too, though, and this is actually a really nice workaround if you don't want to have a super fine mesh before. If you don't want a super fine mesh just for videos, you can get like a reasonable mesh for like calculations, and then bring it in here and refine the mesh with the triangulate and the subdivide to get good looking videos. And you can render it out and have this really nice, realistic looking image. So I think that's it. If anybody has any questions, please leave a comment. You can also comment on the forum about it. I'm going to put a post on there to let everybody know you can do this. But if anyone has any questions, yeah, leave a comment, and I'll see you in the next video.